been trying to figure out what to do with this blog as far as tone. Really want this just to be notes to myself on research stuff so that I can come back and remember what I've looked at before. So that's what I'm really focusing on. So today I'm looking at what I've been looking as far as sequential updates with loops. I have a input module here that sends its output to two nodes. These both send their outputs to a third node at start of a loop. I call it a loop because this module goes, the block sends it out to this block sends the output to this block sends it back. So these three modules are connected together in a loop, to loop 3, loop 4, loop. And they get inputs from here. And now the inputs just go to one here right now. We're working on sequential updates in loops and running some problems as far as the dynamics of it. Here we're getting a chunk of activation, and that feeds itself through the loop, and it keeps going through the loop, kind of builds stronger until at some point it builds it up so that the inhibition will dampen down on it, and we lose all the activation. Right now the inhibition is set to here. One of the problems with this sort of process is that it tends to move in waves, and the inhibition for one module. So if this block gets activated strongly, then the next update, since it's sequential, this one will be activated strongly. We'll get strong inhibition here on that update 2, and it'll clamp down on these activations, but by that time the activation's already moved here. And then this will often be a stronger activation, and it'll then feed it forward. If I click, let's move this up a little bit higher and start updating and see if we can see that. So what we'll tend to see is this cycle of updates, kind of a wave of activations going through these modules as we go. So we get activation here, I'll feed here, feed here, feed here, feed here, feed here, and get stronger and stronger as it kind of feeds. Now at some point the inhibitions tries to clamp down on it, and we may be able to clamp down on this kind of wave of activations that going, but like here what we had is we had a wave of where almost all the cells were activated on one unit, one block, and that activation was sent, and so almost all these cells are activated, and then all these cells are strongly inhibited, and that goes through. Eventually the inhibition will clamp down on everything. We're seeing now where that wave is just dying out, but now we'll see that activation come back in, where we'll get activation moving every update. It moves through here. I'm going to try to move my mouse to see, and then it starts building. Eventually it'll overcome it's overcome the inhibition within the modules. Each of these nodes inhibit the nodes around it relatively strongly, but here we've just got, even with this inhibition, very strong inhibition, we've got this activation. So this node is entirely, this block is entirely active. All that activation is going to make this block entirely active. The inhibition is going to try to clamp down, and so next loop, this will be strongly inhibited the next time. At some point this will die out, but this is just not a very functional loop as we go through, because again everything becomes activated. And it certainly is not processing the data as we want it to. We've got two different patterns that are cycling through here, and this plus and minus shows how common the patterns are as time goes on. So the last couple have been very similar to each other, and then we had a whole section where the previous pattern were they not, and then here was again back 100 updates, similar patterns again, and hopefully this is beginning to mirror that, where we've got similar activations, and then this is the previous pattern, and here the previous pattern was similar to this, so that's nice. But in here we don't really have that. all we have is this chaos where we have really strong activations going back and forth. Now we can get rid of this somewhat. That's why we've switched to instead of synchronous update, asynchronous fixed updates, where we don't update all the cells and move on. And so what that kind of prevents is this the wave factor, where activations go from here to here to here, and we get much less of a wave phenomenon going back and forth with this. We still can get kind of lock up here, where these cells tend to let's turn this up a little bit, see if I can show you lock up. Groups of these cells will basically lock into a set pattern and we won't see much change. So now we're getting close to that, where a lot of these cells are continuously activated, and so these cells will be activating these cells activating these cells, and we're not seeing a whole lot of change. Even with input coming in, these are basically locked into a certain activation pattern and will not be responding to the inputs at all. And so we won't, while we will see a lot of, each pattern is similar to the previous ones, we don't see it. We won't see any correspondence between the input patterns here and the activations here. And if we increase this more, I mean, we'll get even more of that. So like I say, if we don't see, this is where we really start these patterns, and all the patterns are basically similar to each other.